now we will discuss the boundary value analysis, also known as BVA. It comes also under the main type of that we have discussed already, black box testing. The first one was equivalence partitioning, in which from each equivalence partition, or you can say from each equivalence class, we take one value. Boundary value analysis actually is you can say a kind of extension of your equivalence partitioning. Why it is actually extension? Because you see, as the name is suggesting, in equivalence partitioning we only take one value, for example, but sometimes on the boundary there is more chance that your system will not respond as expected, especially on the boundary values. So it is an extension of equivalence partitioning, because in majority of our test cases normally we use both of them together, because boundary value analysis provide or more in-depth knowledge on the boundaries of your system range values. So it's you can say like it's both of them in combination, or maybe they can be used individually, but this boundary value analysis is also one of the very important technique. In boundary value analysis we mainly focus on the boundaries, like maximum value, minimum minus 1, maximum plus 1, only to be sure about the boundary values, because normally the system never behaves as expected on the boundaries. So boundary value analysis is an extension of equivalence partitioning, but only can be used when the partition is ordered. Like first of all, as we have seen in equivalence partitioning, we have like some equivalence classes we have made some partitioning. So partitioning is very important. When partitioning is made, then you can apply boundary value analysis, consisting of numeric or sequential data. The minimum and maximum values, or the first and last values of partition, are its boundary values. For example, we will take an example. We have the range 10 to 20. So the minimum and the maximum, these values they have seen, the first or the last values actually are the boundary. And what we do in the boundary value analysis, this is the max value, you can say, of a particular class or partitioning, and let's say it is the minimum range of our data. So this is the boundary values. Then we check either it's a 2-point boundary value or 3-point. Based on that we check the values beyond that. We will see in detail. For example, suppose an input field accept a single integer value as an input, using a keypad to limit input so that non-integer inputs are impossible, like only integer numbers are possible. The valid range is from 1 to 5. So here the valid range is 1 to 5. So it is your minimum value boundary value, it is your maximum boundary value. Inclusive, both are inclusive. So there are 3 equivalence partitioning they are saying. How they will make the equivalence partitioning, I will explain you on a different, this example I will explain you like this. They have told us that numeric keypad only accept 1 to 5 values. So how they are telling that there are total 3 partitioning, like one is valid range, and greater than 5 till infinity is invalid partitioning. This one we know is valid, and the second invalid is 0 till minus infinity, let's say, it's also invalid. So we have made actually 3 equivalence partitioning in this particular case. Now, so there are 3 equivalence partitioning: invalid too low, as we have seen, valid 1 to 5, and invalid too high. For the valid equivalence partition, the boundary values are 1 and 5. This we have already seen in this example. For the valid partitioning, the boundary values are 1 and 5. So for the invalid, for the invalid too high partition, the boundary value is 6. So if you see, for the this one, let's say for this invalid class, there are 2 boundaries. The infinity, we cannot say that we don't know till which maximum value it is invalid, so we have taken infinity. So that boundary we cannot say which value is it, but this value will know. Greater than 5, or let's say this equal to 6 as well, both are possible. So in this invalid class, the boundary value is 6, and in this valid class the known boundary value is 0, because minus infinity we don't know how far it can go. The boundary value 6. For the invalid 2, there is only one boundary value, which is 0, because this is a partition with only one member. So we can also take it minus infinity, but here they are suggesting it's only one value. In the example above, we identify two boundary values per boundary. The boundary value, the boundary between invalid, too low, and the valid gives the test values 0 and 1. So you see, like, what will be our approach here? We know this is our valid class, so it is min, or then normally for the two boundary value we take min minus 1. So like we check like this during boundary value analysis. This is our max value, we will also take it into consideration, and max plus 1. It is known as, like, on each boundary you are taking two value boundary analysis. Sometimes it is three values. How we do it? Normally with the minimum we also take minimum plus 1 and minimum minus 1. Similarly with max plus 1, max for sure, and max minus 1. So it could be a, like, there are different type, two boundary value, three boundary value, but for ISTQB exam two boundary value analysis will be used. Like in the exam or in ISTQB foundation level we only have two value. So the boundary between valid and invalid too high gives the test values 5 and 6, max plus 1. So the variation of this technique identify three boundary values per boundary, the values before, at, and just over the boundary. In the previous example, using 3-point boundary value analysis, the lower boundary values are 0, 1 and 2, and the upper boundary values are 4, 5 and 6. Like as I have told you, if you are applying, like let's say normally we only apply, like we have this valid range 1 to 5. So if we apply 2, as we have seen, there are two types of. The first one is a boundary value analysis, which is 2-point boundary value analysis, and the other one is 3-point. So if we are going with 2-point boundary value analysis, what we do? We take the min, as I have told you already here, and min minus 1. That mean 1 and min minus 1 0. Then we take max 5, max plus 1 6. So two value boundary analysis mean on each boundary we take only two values, min and minus 1 and max plus 1. But if we are doing 3-point boundary value analysis, that means we have to do min minus 1 and min plus 1. So it is min 1. So what will be min minus 1 0, min is 1, min plus 1 is 2. Similarly for max plus 1 and max minus 1. So we have actually three points on each boundary. It is known as 3-point boundary value analysis. But in ISTQB, as I told you, we only have 2-point boundary value analysis. Behavior at the boundaries of equivalence partitioning is more likely to be incorrect than the behavior within the partition. As we know, as I given an example, if any value from 1 to 5 you take 2, 3 or 4, they will behave in the same way. But values at the boundary are very critical. Normally these are the test cases or values where our system can behave as not expected. So it is important to remember that the both specified and implemented boundaries may be displaced to position above or below their intended positions, may be omitted altogether, or may be supplemented with unwanted addition boundaries. So that's why boundary value analysis and testing will reveal almost all such defect by forcing the software to show behavior from a partition other than the one to which the boundary value should belong. So it's very important when system is in running, like there is possibility of omitting some boundary values or some intended position is not critical. We need to be very precise. Sometimes we have a safety critical system, so in that case we need to check our system beyond the boundary values. Like, is it for example, it should not accept this particular 6 value. Let's say we only have 1 to 5 range, so we should check our system, either it is accepting the value 6 or either it is accepting the value 0. It should not be the case. So that's why we should do the boundary value analysis. Boundary value analysis, again, like equivalence partitioning, can be applied at all test levels. Very important line for ISTQB exam. This technique is generally used to test requirements that call for a range of number including dates and time. So it is very important technique when you have some module or some your object which includes dates and time. So this technique is generally used to test requirement, like where we have the range of numbers. Boundary coverage for a partition is measured as the number of boundary values tested divided by total number of identified boundary test values, normally expressed as percentage. You see, it's a simple formula. How many boundary values you have, they are saying, and then the next one is number of boundary values tested divided by total number of identified boundary test values. For example, over here, if we take in this particular example, we have, for example, 0 and 1, 5 and 6. So we have identified 4 boundary values, and let's say we test only 2 of them, only 1 and 5, then 2 out of 4 means 50% of percentage of boundary value analysis. So it's a percentage which we decide. So this was for boundary value analysis. Now we will jump to decision table testing.